Hello students, in last video we studied about combination and decomposition reactions. Today we go for displacement reactions. The name itself says that displacement reaction means a more active element, here we can take the metal, displaces a less active element from its salt solution or from its compound. A more active one displaces the less active one. So before going to the displacement reactions, we should study about the reactivity series. It's a must and should always. So let us just go for reactivity series. So the reactivity series is the one where we place all the metals in the decreasing order of reactivity. That means, so potassium is highly reactive, barium, sodium, calcium and magnesium. Actually we can consider them as a highly reactive elements. So in this group also potassium is highly reactive, less is barium, sodium, calcium and magnesium. And next we can go for the next group, moderately reactive elements, aluminium, zinc, iron, nickel, tin and lead. Aluminium, zinc, iron, nickel, tin and lead are again the moderately reactive and again in the decreasing order. We place the hydrogen in between. So mainly because to study about the displacement reactions only. Next one is least reactive. We have copper, mercury, silver, gold, platinum again in the decreasing order. So why should we place a hydrogen which is a non-metal in this metallic series? So just to know that, so the metals above the hydrogen, they displace hydrogen from the dilute acids. The metals which are below the hydrogen, they do not displace hydrogen from the dilute acids because metals below hydrogen are less reactive than hydrogen. The metals above the hydrogen are more reactive than hydrogen. So that's why this reactivity series is very important. This is metal reactivity series. We have separately a non-metallic reactivity series also there. But in the 10th standard only we study about metal reactivity series and you should learn in the decreasing order. Let us have the example of displacement reactions. One example is which they have given in your NCERT textbook is the reaction between copper sulfate and iron. What we do is we will take aqueous solution of copper sulfate, which is an aqueous solution. First we take the crystals of copper sulfate, dissolve with little amount of water. It will dissolve in water very well. We call it as aqueous solution of copper sulfate. We get deep blue color, deep blue colored solution of copper sulfate and we dip an iron nail into it, which is grey in color, you may be knowing. And when we dip iron nail in the copper sulfate for about 20 to 30 minutes, so we get ferrous sulfate, FeSO4. So again it is an aqueous solution plus, so the copper will be displaced. You may be knowing copper is less reactive than iron. Iron is more reactive compared to the copper. It is a compound of the copper. Iron displaces copper from the copper sulfate solution. We get iron sulfate. So we get iron sulfate and copper. So copper is having reddish brown in color. So which will be actually appeared as a coating over the iron nail and this is pale green in color. So the color of the ferrous sulfate is pale green. Slowly the color changes from deep blue to pale green color. So this is a very good example for displacement reaction. Next one you can go for ferrous sulfate FeSO4 plus zinc. So it's an aqueous solution. What is the color? Which is again pale green in color and zinc is solid again which is grey in color. We get zinc sulfate ZnSO4 which is colorless, which is actually colorless and iron gets displaced. You can just observe, compared to iron, zinc is more reactive. So zinc displaces iron from the ferrous sulfate solution. So it's a compound of iron, it will be displaced if we get zinc sulfate and iron. We can have some more examples here, calcium sulfate and potassium. Example we can take CaSO4 plus potassium. The reaction will be vigorous because both these elements are highly reactive. We get potassium sulfate K2SO4 plus calcium will be displaced because potassium is more reactive than calcium. So we can have the example of zinc chloride ZnCl2 plus aluminium. Even aluminium is more reactive compared to zinc. So we get aluminium chloride plus zinc will be actually displaced. These are all examples for the displacement reactions. Hello students, today we study about the double displacement reactions. The reaction, the name itself says that displacement reaction takes place in both these reactants. Observe, these reactions are actually ionic compounds. There is a formation of ions when we just dissolve it in water. So sodium ion, sulfate ion, barium ion and chloride ion, and there is an exchange of ion takes place between these two reactants, and then we call it as, these reactions are called double displacement reactions. Let us have one example how these reactions takes place. Sodium sulfate. So the salt of sodium sulfate, solid, just dissolve in water, we get an aqueous solution of sodium sulfate. Same manner, take barium chloride, solid, crystals of barium chloride, dissolve with little amount of water, we get barium chloride aqueous solution, and the reaction takes place like this, we get barium sulfate and sodium chloride. So we get barium sulfate, BaSO4, which is a solid insoluble in water. We call it as actually the white precipitate. PPT means white precipitate of barium sulfate will be formed, and we also get sodium chloride, NaCl. So this is a very good example for a double displacement reaction. Sodium sulfate aqueous solution, barium chloride, we get barium sulfate and sodium chloride. So in any precipitation, solid insoluble white precipitate, it is insoluble in water, so we can call it as a white precipitate. Sodium chloride is soluble in water, an aqueous solution of sodium chloride. So this is an example for double displacement reaction. Next one is lead nitrate aqueous solution. Take lead nitrate salt, dissolve with water, we get aqueous solution of lead nitrate, and potassium iodide. So we get actually potassium nitrate and lead iodide. So lead iodide PbI2, which is again insoluble in water, which is actually yellow precipitate, yellow colored precipitate is formed, and we get one more aqueous solution, potassium nitrate, KNO3. So this is again a very important one more equation for the double displacement reactions. So next one we can go for is the sodium chloride and silver nitrate solutions. Take aqueous solution of sodium chloride and aqueous solution of silver nitrate. We get silver chloride, white precipitate and sodium nitrate. So we get AgCl, we can write it as solid white precipitate of silver chloride, and one more is actually sodium nitrate, NaNO3, which is again aqueous solution. So aqueous solution means the salt which is dissolved in water, so it is actually soluble, and we get white precipitate of silver chloride. All these reactions are very important in double displacement reactions.